Okay. Give heading fractions. So I'm asking the last question that we have discussed. Can you tell me the start of the question? Last question that we have discussed. In the year? Hmm. Please continue. Okay, no problem. But what was the last question? Because of that, I can continue the same. The topic was mathematical operations? Okay, no problem. So why are you sitting there only? We have lots of space here. Okay, no problem. So today's topic is fractions. Fractions is basic topic for percentage as well as ratio also. Again, percentage is basic topic for profit and loss, interest applications, you can say. Then ratio is basic topic for proportion. Then types of proportions, in that direct proportion, inverse proportion. Based on that, we have time and work questions, time, speed, distance questions, then problems on trains and boats, and before that, from ratio itself, partnership, allegations or mixtures, like that. Okay, so basically we have the basic topic, that is fractions. First of all, we should get meaning of this one, then types of fractions, then we have conversion of these types of fractions, means numbers or fractions are converted from one to other, like that. Then we have comparison of fractions. Then we have operations on fractions. And at last but not the least, examples, basics as well as applications, word problems also. So first of all of us know meaning of the word fraction. What do you mean by fraction? Generally, we know part of a whole, means whatever is the group we are having number of items, out of which if we are taking sum of those, then we can say what that is nothing but part of a whole. So for example, in this class, suppose there are 200 students. Out of these 200 students, if boys are 125, then but obvious girls are remaining, these are 75. So suppose you are asked that what fraction of total students are boys. So what fraction of total students, that means total students are to be written in the denominator. So that is numerator denominator form. So 200 out of 200, how many are boys? 125 are boys. So that is a fraction representing boys out of the total students. So that is what, to the lowest terms, we can say then it is 5 upon 8 when divided by 25 each. So 5 by 8 is a fraction representing number of boys out of the total students in a class. So but obvious remaining are girls. Out of 8 equal parts, boys are 5. So that is nothing but out of 8, remaining 3 parts are girls. So that is 3 by 8 is number fraction representing number of girls. Again, moreover, in this one, as we have out of total 200 students, so what fraction of students? That means in the denominator we have to put all given distribution, that is 200. So because of that, suppose among those 125 students, suppose there are 75 students who have 75 boys. Just a minute. Out of 125 boys in the class, if 75 boys have scored more than 90% marks, suppose. So what fraction of boys are getting more than 90% marks? So in that case, we have what fraction of boys? In the denominator, what should we write? 125, that is total number of boys. What fraction of boys? So in the denominator, whatever is total number of parts made, that is 125 boys, out of which how many are getting more than 90%? 75. So in that case, we have the fraction representing boys who are getting more than 90% marks, that will be here we have 3 by 5. Is it clear? So that is meaning of this fraction. So again, here we are getting this one part of a whole. Suppose there is a number of items in a group which are to be divided equally, but that number, if it is not completely divisible by, how many groups are to be made? For example, suppose we have 75 things and to be distributed equally among here 40 students. So in that case, 75 is to be divided by 40. Is it clear? So here we are getting a fraction. So that is not part of a whole, but it is representing fraction because number in the numerator is divided by number in the denominator. So number in the numerator is greater than that of the denominator. So we have this one is meaning of fractions. Then according to style of writing these fractions, there are types of fractions. So basically there are two types of fractions. Which are those here? Those which are expressed in numerator denominator form, these are called common fractions. These are also known as vulgar fractions also. And second type is decimal fractions, the fraction which are expressed with the help of decimal point. Now, common fractions are again of two types. Before going to the types of common or vulgar fractions, here these are expressed in numerator denominator form. Is it clear? So the fraction which is expressed in numerator denominator form is called common fraction. Now in some of the fractions, in some of the common fractions, numerator is greater than denominator. In some of the fractions, numerator is smaller than denominator. When numerator is smaller than denominator, that is part of a whole we are expressing, so that fractions are called proper fractions. So where numerator is smaller than denominator, and here when numerator is greater than denominator, then these are called improper fractions. Is it clear? Okay, so we can have some examples. You can write any fraction whose numerator is smaller than denominator. For example, we have 7 upon 29 or 11 upon 63, like that. Is it clear? Then we have improper fractions. Examples are, you can just put reverse of this, means reciprocals of the here. Only we have to take into account that the number in the numerator should not be completely divisible by the number in the denominator. So 29 by 7 or 63 by 11, like that. Is it clear? After this one, let me tell you why are these called improper fractions, because these can be converted in mixed numbers. Is it clear? So improper fractions can be converted in mixed fractions or mixed numbers. How can this be? So when we are having 29 by 7 an improper fraction, so 29 needs to divide by 7. So we know that the integer is 4. 7 4 is 28. Remainder is 1. So we have 4 integer 1 upon 7 to read this one. Is it clear? How can you read 4 integer 1 by 7? So here UPSC will never ask you, but you should know that one. I would like to ask the same. So here 4 integer 1 by 7, all of you can read. What is the sign between 4 and 1 upon 7? Are you getting my question? What is the sign between 4 and 1 upon 7? Okay, so all of you are saying plus. How many of you are saying plus? Please raise your hands. Ah, correct. Plus only. It is not multiplication. I can understand those who are saying multiplication because they know that 7 4 are 28 plus 1, like that. So here it is 4 integer. I'm reading 4 integer 1 by 7. So 4 and 1 upon 7, and that is plus. 4 is nothing but 4 integer, that is 4 upon 1 plus 1 upon 7. As in addition or subtraction, we make denominators equal. So here it is 4 integer, that means 4 has denominator 1. To make it equal to 7, for that we have to multiply the denominator by 7. Not to change its value, we have to multiply numerator also by the same number. And that's why it is 4 upon 1 is nothing but 28 upon 7 plus 1 upon 7, that is 29 upon 7. So which is sign between 4 and 1 by 7? Plus only plus. Is it? Okay. Now here these are the types of which fractions, common or vulgar fractions. Listen, we will write afterwards. First of all, we'll go for decimal fractions also first. Okay. So here decimal fractions are again of two types. Which are those? Terminating decimal fraction, and second one is non-terminating. Okay. Now you will write afterwards. Please listen first of all. Terminating. The word terminate means ends, division ends. So somewhere division ends, that means here number of decimal places is finite. For example, exactly one number of decimal place or 2 or 3, like that. So for example, we have 0.5. It has only one decimal place. So that is why it is terminating decimal fraction. Then 3.14 is also terminating decimal fraction. Okay. Now in non-terminating, that means division never ends. So again, there are two types of fractions then. What are those? One is recurring decimal fraction. Recurring, and second one is non-recurring. So in case of recurring decimal fractions means what? A single digit or group of digits is repeating again and again for infinite number of times in the same sequence. So that is called recurring decimal fraction. For example, 0.555 ... A single digit is repeating again and again for infinite number of times. We can express this one as 0.5 recurring, right? So we can put dot or a bar there. Now here we have, for example, 3.141414 ... That is 3.14, and two digits are repeating again and again. That's why we have to put a bar on that group. So here we have a pair. So not necessarily only a single digit or two digits are repeating again and again different. There may be 3, 4, 5 groups of 3 digits or 4 digits or 5 digits repeating again and again in the same sequence. So that is called recurring decimal fraction. Is it clear? Now non-recurring. So as in first topic we have seen these non-recurring. That is nothing but root 2. What is it? 1.4142 ... It is neither terminating nor recurring. Is it clear? Okay. So root 3 one and the same. 1.732 ... Neither terminating nor recurring. So these are what type of numbers? These root 2, root 3, their values. These are irrational numbers. In first topic only we have seen all these. Rest all means all common fractions as well as the terminating as well and recurring decimal fractions are rational numbers. Is it clear to all of you? Got this one? So if you are interested, you can copy this one. Just a minute. Let me make it comfortable. First of all, do this one. All of you can get it properly. Okay. So in the center you have written fractions. One type is common or vulgar fraction, that is nothing but numerator denominator form. Then second one is decimal fraction. In common or vulgar fraction there are two types: proper as well improper. Improper fractions can be converted in mixed numbers, but proper fractions are being numerator smaller than denominator. They are not converted anywhere. So you can put examples for proper improper fractions and then mixed numbers. Till this finished. Then we have decimal fractions. Again, one type is terminating, second one is non-terminating. In terminating decimal fractions, we have examples are with finite number of decimal places, exact number of decimal places, maybe 1 or 2 or 3, like that. So example 0.5, 3.14, like that. In case of non-terminating decimal fractions, again two types. One is recurring, second one is non-recurring. In recurring decimal fraction, we have a single digit or two digits or group of 3, 4, 5 digits repeating again and again for infinite number of times, and then non-recurring are root 2, root 3, their values. Finished? Okay. So after this one, please write down subtitle: Convergence of fractions. Convergence of fractions. Friends, in our prelims in 2020, there was a question, conversion of fractions. We'll discuss afterwards. Right now, first of all, we have to check all these basic things from conversion point of view. So conversion of fractions. First of all, from common fractions to decimal fractions. Common to decimal. All of you present here can convert any common fraction into decimal fraction. All of you. Okay. So for example, I would like to give you example. Please convert this one. 5/8. Just to start. 5/8. If you are converting this 5/8 in decimal fraction, all of you can do. Not necessary to tell the answer, just for your information only. 5/8. When it is common fraction, you can convert it in decimal fraction. Okay, so not necessary to tell the answer. It is no doubt 0.625 you are getting. If not, then please listen. Okay. We have 5/8 is a common fraction. To convert this one into decimal fraction, the safest way or the basic for any example is dividing the number in the numerator by number in the denominator. So that is the only thing. So because of that, you might have doing like this one. 5 is divided to be divided by 8. Being 5 smaller than 8, first of all, we have to put 0 in the quotient. Then subtracting 0 from that one, we have 5 again. Now, after this 5, we have to put a decimal point, and then all of you believe in this thing that there are you can put any number of zeros there. Now we have to drag next digit before that there is decimal point. That's why in the quotient we have to put the same. 0 when drag, we have 8. So 6 are 48, remainder is 2. Then we have to drag another digit, that is 0. So 8 2s are 16, remainder is 4. Again, we have to drag the next digit, that is 0. So 40 is in 8 table. So we have 8 5s are 40. So remainder is 0. Being remainder 0, we have to stop there only. No doubt. So because of that, we have what is the quotient here? 0.625, which is a terminating decimal fraction. So let me tell you the most important sentence regarding the same. Any common fraction, if it is to be converted in decimal fraction, that means number in the numerator when divided by number in the denominator, it will be anywhere, it will be somewhere the remainder 0. First of all, one case, it will be remainder somewhere 0. In that case, we have a terminating decimal fraction. If remainder is never 0, in that case, it has to be recurring only, compulsory. When numerator is divided by denominator, if remainder is not 0 anywhere, then that converted decimal fraction must be recurring decimal fraction only, anywhere. Is it clear? So first of all, as soon as you get the fraction, common fraction 5/8, the number in the denominator itself tells us that whether it will be terminating or recurring. Let me tell you how it is. So when we have this one, 0.625 is a decimal fraction which is terminating. Okay, first of all, I would like to ask you a simple question regarding this one. In the number 0.625, can you tell me what is place value of the digit 6? Are you getting my question? What is place value of the digit 6 in this 0.625? You have to tell, otherwise I will tell. No doubt. Please, no one will say anything. Please tell whatever you want to tell. Okay, I have to tell 6/10. Is it clear? Then 2 has 2/100. Then 5 has, now you all are getting the same, 5/1000. Is it clear? So that is 0.6 means out of 10 is 6. 0.02 means out of 100 only 2, like that. So when we are adding these, is it clear to all of you? Then we have just a minute. Here to make denominators equal, we have to multiply by 10 here, so it's the same. We have to multiply by 100 here, so same here. So this is nothing but what is it? Upon 1000. And in the numerator, what is it? 600 plus 20 plus 5, that is 625/1000 is, we have the same. Is it clear to all of you? Got this? Okay. So in first topic only in number system, we know that any number is the sum of place values of all the digits in it. Same is the case here also. In decimal fraction, whichever is the decimal fraction given, whatever the place or local values of the digits, when these are added, we get the equivalent number. Is it clear? So that is okay. So right now, as we are having, when terminating decimal fraction it is, then when it is to be converted in common fraction, then its denominator is powers of 10. If there is a single decimal place, we have upon 10. When there are two decimal places, we upon 100. There are three decimal places upon 1000. So in the powers of 10, 10 raised to 1, 10 raised to 2, 10 raised to 3, like that. So because of that, here now come to this point that, as I said it, as soon as we see the number in the denominator of a common fraction, we realize what can be the type of a decimal fraction, whether it is recurring or terminating. How it is? 8 has factors. In the next topic, we are doing H7 and HM, and before that, all of us know what are the factors of 8. Factors of 8 are 2 into 2 into 2. Are you getting me? Is it clear? Now listen. So to make 10, each 2 needs to be multiplied by 5. Are you getting me? So if you are getting the number in the denominator having factors in only 2s and 5s, any number of 2s and any number of 5s, doesn't matter. Here, if there are 2s and 5s only, then when we convert that one in decimal fraction, it has to be terminating decimal fraction only. Are you getting me? How it is? Because each 2 is to be multiplied by 5. So because of that, this 8 when multiplied by 5 thrice, that is 5 into 5 into 5. So not to change its value, in the numerator 5 also needs to be multiplied by 5 each, here by 3 times. Is it clear? Got this one? So because of that, we get 8 into 5 into 5 into 5, that is 1000, and 5 into 5 into 5 into 5, that is 625, that is 5 raised to 4 is 625. So any number in the denominator having factors only in 2s and 5s, as I said, any number of 2s and 5s doesn't matter, right? So you will be getting the same. Is it clear? Okay. So that is conversion of any common fraction into decimal fraction. So from, for example, please take down another number, 17/40. Please do this one. 17/40. By any method, you can get the answer, no doubt, whichever is comfortable for you. Okay. So here 17 upon 40. If you have divided that 17 by 40 or 17 by 4 first of all, and then shifted one decimal place to the decimal point one place to the left. Okay, you can do. Otherwise, 40 has factors. 8 5 are 40. So because of that, 8 is nothing but 2 into 2 into 2 tries 2 and 1 5. 2 into 5 already it is a 10. Right? So here once 2, then we have another 5 and here is 5. So equal number of 2 and 5 must be there. Is it clear? So here 3 times 2 and once only 5. So we want twice 5. So in the numerator also 17 needs to be multiplied by 5 twice. Is it clear? Got this one? So 2 into 5 is 3 times and that is what it is. 1000 in the denominator and in the numerator. 17 into 5 into 5 that gives you how much? 425. And hence we have the answer is 0.425. We have to read this one 0.425 only like this one. Is it clear? Okay, so that is conversion of common fraction into decimal fraction. When common fraction converted in decimal fraction, first of all, we are getting these two examples. When decimal fraction, we are getting that is terminating, right? But right now, I would like to ask you the same. Suppose we have to express this 17, okay, no problem, 17 upon 12. As soon as we get this fraction 17 upon 12, you will realize what type of a fraction will it be in the decimal. Will it be terminating or recurring? It has to be recurring only because factors of 12, 2 into 2 into 3. Okay, no problem, there are 2s, but 3 is also there. So such factors must be in 2s and 5s only. Even if there are 2s and 5s, but other than 2s and 5s, if it is another factor, then we have no doubt has to be recurring decimal fraction only. So when 17 divided by 12, it needs to be divided by, sorry, it is manually only. 17 needs to be divided by 12. We have 12 ones are 12. What is the remainder there? 5. So 50 it will be. Then 12 fours are 48. Then 2 remaining. Again 0 we put 20. 12 ones are 12. What is remaining there? 8. Then 80 it will be. So 12 6 are 72. Again 8 it will be. Then again 80. Then again 12 6 are 80. Now it will be endless. So it is 666 for all the time. So it's a partial recurring. It is not fully recurring. We'll discuss afterwards the partial and full recurring. So here 1.41 and only 6 is recurring again and again. Is it clear? Got this one? Okay. So these are some of the examples from conversion of common fractions into decimal. So when we are getting the denominator having factors in all 2s and 5s only, then decimal fraction will be terminating. If it is any factor other than 2s and 5s, then it has to be recurring decimal fraction. Is it clear? So for example, suppose 15 upon 11. Can you tell me what is a conversion in decimal fraction? No doubt it will be recurring, but you please tell me the same. Please do these calculations. No doubt I'm saying recurring it will be, but you tell me just exact what is the fraction. I'm saying the same. Please solve, I said. 11 being a prime number, it has factors 1 and 11 only. So you need to divide 15 by 11. So it is, when you are dividing 15 by 11, it is 1.363636 recurring. That is 1.36 recurring, and it is fully recurring because in the decimal places there are 2 different digits and these both repeating again and again in the same sequence. That is recurring decimal fraction. Is it clear? Every time after dividing 15 by 11, alternately, you are getting remainders 474747 like that. So that is what 363636 are the digits in the decimal places infinite number of times. Is it clear? At last but not the least, I would like to ask you 22n divided by 7. Just minute, first of all, we'll discuss and then 22 upon 7. If it is converted in decimal fraction, what type of decimal fraction will it be? Compulsory, it should be recurring. It should be recurring because denominator is 7, that is being a prime number having factors only 1 and 7, and because of that, no doubt it has recurring decimal fraction. It will not be terminating. If it is not terminating, then it's a compulsory. It should be recurring. So 22 and divided by 7, we get 3.142857. Again 142857. Again the same. So that is recurring. So we have 3.142857, and here we have to put back on those 6 digits. Group of 6 digits is repeating again and again in the same sequence for infinite number of times. Is it clear? Got this one? So these are all the things from conversion of common fractions into decimal. These will be either terminating or recurring. Now it's a reverse. Now conversion of decimal fraction to common fraction. So decimal to common fractions. Listen, there are 2 things. Conversion of decimal to common. First one, you can convert any terminating decimal fraction into common fraction. It's very easy. So first of all, terminating, as I said it. So here we have 0.5. It is a terminating decimal fraction. If it is converted in common, what is it? 5 upon 10, first of all, that is nothing but to the lowest terms, it is 1 upon 2. Why it is 5 upon 10? Because it's only one decimal place, and that's why upon 10. So 5 upon 10 to the lowest terms, it is 1 by 2. Now here, I'd like to ask you, 0.41, when it is to be converted in decimal, what is it? Sorry, converted in common, what is it? 41 upon 100. So simple, as all of you know. As equal number of zeros on 1 to be put in the denominator for number of decimal places. Or number of decimal places is 10's power, whatever. Is it clear? So that is what terminating decimal fraction to common. Now, as you know, here 0.3, it is only, then it is again terminating, it is 3 upon 10. But in case of recurring decimal fraction, I'd like to ask you 0.333333 dot dot dot. That is 0.3 recurring. Can you tell me what will be the common fraction equivalent to this one? Please raise your hand in detail. Are you getting my question? 0.333 recurring. If it is converted in common fraction, what is its equivalent? Yes, please. Okay, absolutely correct. It is 1 by 3. But why it is 1 by 3? How it comes 1 by 3? Are you getting my question? 1 by 3 is absolutely correct. 0.3 recurring has its a common fraction equivalent is 1 upon 3. No doubt. But how it is? As I asked. Okay, no problem. I'll ask the same. For example, 0.4444 dot dot dot. So 0.4 recurring. Now, can you tell me what is the common fraction? Equivalent common fraction? Okay, please don't discuss directly. Talk to me only, please. Okay. So we are not wasting our time. Let me tell you. 0.3 recurring has its a common fraction is 1 upon 3. But why it is 1 upon 3? Because it is 3 by 9. Let me tell you first of all. It is 3 by 9, and that's why to the lowest terms, it is 1 upon 3. Okay. Now, here 0.4, just online friends, they want to say something. Okay. Okay. After you said the same 1 upon 3, but I asked why it is 1 upon 3. So it is because 3 upon 9. So to the lowest terms, it is 1 upon 3. Same is the case. 0.4 recurring. That is what? 4 upon 9. It is common fraction. 4 upon 9. We'll discuss all these things. First of all, let me tell you these basic. Okay. 0.414141 dot dot dot. That is 0.41 recurring. No. You will have to please listen first of all. Look at this one. 0.414141 recurring. That is 0.41. These are the two digits repeating again and again. So it is 41 upon 99. Are you getting me? So now you all are getting the shortcut. So what is it? For example, 0.67367367 just a minute. 673 dot dot dot. That is 0.673 and 673 recurring. All of you present here in the class, offline as well as online, are getting the same. What is it? In the numerator, what should be the number? 673, and in the denominator, 999. So equal number of lines are to put. How many digits are repeating again and again? And in the numerator, the number formed by the digits in the decimal part. Are you getting me? Is it clear? So why is it so? I have to explain, no doubt. So let me tell you, 0.3333. Listen, this one, and based on the same, it was the question asked. It will be very now you will be comfortable at that point. See, 0.3333 recurring, it is given. The most important sentence regarding simplification point of view, I would like to tell you. In maths, if we are given any expression with infinite terms, here, how many decimal places are there in this 0.333 recurring? Infinite. Is it clear? Endless. Infinite. So when we are having infinite terms for any expression, let it be any variable. Let it be any variable, x, y, z, whichever you like. So let it be x. Are you getting me this one? Let it be x. Now, as we have 0.3333, a single digit is repeating again and again. That's why we have to shift one decimal place to the right by for this decimal point. Are you getting me? We have to shift the decimal point by one digit by one place to the right. I'm saying that means we have to get 3.3333 dot dot dot. Are you getting me? So to make this one, we need to multiply by 10. We have to multiply by 10. In other words, we have multiplied by 10 only to this relation. So it is 10x. Is it clear? 3 plus this 3.333 and that is 3 plus 0.3333 dot 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 is equal to 10x. Are you getting me? So 3 plus for this one we assume x. Is it clear? So what is it? Is equal to 10x. Now, x when transposed to the opposite, it is minus. So it is 9x is equal to 3. Are you getting me? And because of that, x is equal to 3 upon 9. As I said, you told the answer 1 upon 3. Why? Because it is 3 by 9. So we have 3 by 9. To its lowest terms, it is 1 by 3. Whatever the lowest term, that is not important from concept point of view, first of all, from shortcut. It is 1 upon 3, the final answer we are getting after getting it to the lowest terms. But before that, what is it? 3 upon 9. Is it clear? Okay. So in the second, as we discussed the same, we have 414141. So 0.414141 dot dot dot. Let this one as y. Is it clear? How many different decimal places are there? How many different digits in these decimal places? 2. So that decimal point is to be shifted to the right by 2 places. In other words, we have to multiply by 100. It has to be multiplied by 100. So we have 41.414141 dot dot is equal to 100 y. As all of you know, 41 plus this 0.414141 is nothing but y is equal to 100 y, and hence we have 99 y is equal to 41, and that's why y is equal to 41 upon 99. Is it clear? So same is the case. You can put 0.673 673 dot dot dot. Let it be z, and you can put directly z is equal to from shortcut point of view. Here z is equal to what is it? 673 upon 999. Is it clear? What is one? If you are interested to copy this one, please do within no time. Okay, finished. Same is the case here for the second one. 0.414141 recurring, assuming it as y. Okay. And then we have 0.673. You can put 0 for that as the variable z, and z is equal to 673 upon 999. Now, not necessary to make all these steps, and you can directly use a shortcut, as I'm going to tell you 2 or 3 sums for that one. Okay, so 1.363636 recurring. That is 1.36 recurring. So can you tell me what will be its common fraction? What will be its common fraction? Please do it in your notebook, paperwork. Please do that paperwork. 1.363636 recurring. Yes, please. Okay. So listen, first of all, as I said it, you can apply shortcut. First of all, integer part is not to be included in this shortcut. So that is what integer part is 1. Decimal part is 366 recurring again and again. How many digits are repeating? 2 digits are repeating. So in the denominator, what should it be? 99. In the numerator, the number formed by the digits which are repeating. All the here, that is 3, 6. Is it clear to all of you? What is 1? Now, to the lowest terms. 36 as well as 99 both are divisible by 9. So that is what 9 4s are 36 and 11 9s are 99. So because of that, we get 1 integer 4 upon 11. First of all, anywhere when we have such a number, it is to be expressed in this fraction only. But if it is to be converted in improper, we all know 11 ones are 11 plus 4, that is 15 upon 11. Is it clear? So in the first one, as we converted common fractions into decimal, we got 15 by 11 as 1.363636 recurring. Same, we reverse this one. Are you getting it? Is it clear? Okay. Now, based on the same, as in prelims 2020, there was a question. So here, let me tell you the question. Here, all of you are getting question paper from 2020. Question number 53 here, I think. Yes. Question number 53. We have the recurring decimal representation 1.272727 recurring is equivalent to the same question. Okay, try to get the same. All of you present here are getting correct answer. Online friends, you are also getting the same correct answer. Here we have 1.272727 recurring. That is, integer part is 1. Then decimal part is with 2 different digits repeating again and again. There are only 2 different digits and both are repeating. That's why 99 in the denominator and in the numerator it is 27. Because of that, we have 3 9s are 27, or 9 3s are 27, and here 11 9s are 99. So we have 1 integer 3 upon 11. But all these options are improper fractions, and because of that, 11 ones are 11 plus 3, 14 upon 11. So hence the answer is option D. So simple. Okay. Online friends, is it clear? Offline, I'm asking, no doubt. Okay. Is it clear to all of you? Now, the next one I'd like to ask. See, 0.617. 171717 ... So let me tell you, 0.617 and only 17 are recurring. Are you getting this example? 0.617, 171717 recurring. It is not fully recurring now. Here, integer part is 0 only. Fractional part has how many different decimal? How many different digits in decimal places? 3. Right? So 3 different decimal places, but of which only 2 are repeating again and again. So here, from shortcut point of view, only you should be able to get the same. That's why I'm explaining all these things, and finally we'll come to the here conclusion. So let this one as x first of all. Right? How many different digits are there in the decimal part? 3. So that decimal point is to be shifted by 3 places to the right. First of all, it means it needs to be multiplied by 1000. So because of that, 617.171717 ... is equal to how much should I write? 1000x. As you know, is it clear? Now listen. In previous examples, we got that whatever is after decimal point, that was assumed as x or y or any variable. But here we are assuming x for the entire, first of all, and then we are not getting that 0.171717. So for that, what we have to do? No doubt, 617 plus 0.171717 it is. So to cancel plus 0.171717, we have to subtract the same. So to have the same decimal part, what we need to do in the given expression, those digits which are repeating again and again, these are only 2, which are those 1 and 7. Where is 1 comes first, after 6 immediate next. So that decimal point is needed to be shifted to the one to the right by 1 place only. Are you getting it? Is it clear? It will be said fully recurring only when the decimal point is shifted by 1 place to the right. Is it clear? To shift one place to the right for the decimal point, we have to multiply by 10. Is it clear? So that is what we are doing. 6.171717 recurring is equal to how much it is? 10x. Is it clear? Okay. So this is the first equation, this is second one, and this is third. Subtracting third relation from the second one. What happens? 0.171717 recurring being same to both will be cancelled. So what is remaining there? 617 minus 6. No doubt we can do subtraction, but right now, from shortcut point of view, I have put as it is. So 617 minus 6 is equal to, in the RHS, what we have to write? 990x. So x is equal to 617 minus 6 upon 990. Is it clear? Is it clear to all of you? So that x is nothing but we are assuming for the given expression. Now, shortcut or analysis you can have. Here, in the denominator, what is it? 990. 990. So that is what the 2 digits being repeated again and again for that equal number of 9. That is 2 9s are there. And there is a single 0 is because of a single digit in the decimal part is not repeating. So for that equal number of zeros are to put. If there is a single digit not repeating, single 0. If there are 2 digits not repeating, 2 zeros. So equal number of 9s and zeros are for the digits which are repeating and non repeating respectively. Is it clear? So you can form a denominator of such a partial recurring fraction. Is it clear? Now in the numerator, first of all, get the number formed by all the digits in the decimal part. First of all, that is 617. Minus what to do? The number formed by the digits which are not repeating. The number formed by the digits which are not repeating, that is minus 6. Is it clear? What is 1? So finally it will be 611 upon 990. So whatever is finally that you will be getting afterwards. Are you getting this concept of shortcut? It is needed. In the denominator, it is all the time in the combination of 9s and zeros only. only 9s and zeros in the denominator initially. And in the numerator, number formed by the digits in decimal part minus the number formed by the digits which are not repeating. So from shortcut point of view, I would like to ask you example. So you can apply shortcut 0.61777 dot dot dot. So here it is. In the denominator, step by step. In the denominator, what should it be? Okay, or otherwise, not to confuse. Here we have 0.617 and only 7 is recurring. Now tell me, what should be the denominator? 900. Are you getting? Here, once 9 only, because 1 is the digit which is repeating again. The single digit is repeating again and again. How many digits which are not repeating? 2. That's why 2 zeros to put. Is it clear now? Okay. In the numerator, first of all, it is 617 minus what is it? 61. Is it clear? Number formed by the digits which are not repeating. Is it? So whatever is the calculation that you can do. Okay. So let me ask you in the same. Just a minute. Here we have 1.41666 dot dot dot. Please do this one. Rishikesh, repeat this method with one more example as you asked. Okay. Actually, what do you want to ask exactly? You can unmute and talk to me. Please apply shortcut here for this one. Okay. Upon. Okay, no problem. So I asked to show you the same as we did in the previous one. Converted common to the decimal. Now we are converting decimal to common. Listen, 1.41666 recurring. That is 1.41 and only 6 is recurring. So one integer as it is. There are 3 different digits in the decimal places, out of which only single is repeating. So single 9. 2 digits are not repeating. Double 0. In the numerator, 416 minus 41, friends. Is it clear? Minus 41. The number formed by the digit which is not repeating. So one integer, 416 minus 41. How much it is? 375, no? So 375 upon 900. Is it clear? So to the lowest terms, now we can do the same. To the lowest terms. Here, both are divisible by 25 as we get. So when 375 is divided by 25, it comes 15. And here, when 900 divided by 25, it comes 36, no? 36. Now again to the lowest terms, when divided by 3 each, 3 5s are 15, and here is 12. So one integer 5 upon 12, we are getting one integer 5 by 12. That is, if it is to be expressed in improper fraction, it is 17 by 12. Is it clear to all of you? Now, as I would like to show the same. Here we got 1.41666 recurring again and again. That has equivalent fraction in common fraction, that is 17 by 12. Same we got the just a minute. Same we had in when converted common fractions into decimal. Here we got 17 by 12. That is 1.416 recurring. Is it clear? We have converted both common to decimal and decimal to common. Okay, so partial recurring as well as fully recurring. Yes, from online friends, Atreya, you are right. Okay, so that is I wanted to tell you the conversion, right? Okay, have you copied this one, please? Okay, so that has been conversion. So we have till this one seen meaning of the fraction, then types of fractions as well conversions. After this one, we have next subtitle is comparison of fractions. So please write down subtitle comparison of fractions. Okay, so from comparison of fractions point of view, you may be given 2 or more fractions. If there are 2 fractions, then we have to compare which is smaller and greater. If there are 3 or more, then smallest, greatest, or in arranging them in ascending order or descending order. So right from your school days, you know the basic things. Based on that, I would like to ask you some questions. So here, I would like to give you. Please write down instruction. Find the smallest fraction. Find the smallest fraction in each of the following groups. Find the smallest fraction in each of the following groups. Okay, so first group I would like to give you 2 upon 13, 5 upon 13, 9 upon 13, 11 upon 13, 17 upon 13. So as I asked, which is the smallest fraction? So all of you present here are saying the same thing. What is it? No one will say 17 by 13. Here it is 2 by 13. Why is it so? Even in what you may say, primary school also till third or fourth standard. The teacher may tell the students that there is a cake and divided in 13 equal parts, out of which 2 are taken, 3 are taken, like that. So out of these 13, only 2 are taken. So that is the meaning of this one. Is it clear to all of you? Right from very basic things we are doing. Second one, second group, 13 upon 2, 13 upon 5, 13 upon 9, 13 upon 11, and 13 upon 17. Which is the smallest one? 13 upon 17. Why? Because all are having same numerators. The fraction with the greatest denominator is the smallest. Is it clear? Before that, in the first group, each fraction has denominator 13 that is same. So these are called like fractions. These are called, first of all, in first group, these are called like fractions. Is it clear? Like fractions. So like fractions can be easily added or subtracted, as you can say. Okay, yes. Yeah, I'm getting the same, but okay. Do you have a remote there? No one? Okay. Actually, I was getting this. I was supposed to get the same. Hello? This is a remote part of the okay, it will be the next. Next group is 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6, 6 upon 7. So, so you got 26 minus minus plus. It's just minus. Oh, so next question, group of fractions, 2 by 3, 3 by 4, 4 by 5, 5 by 6, and 6 by 7. Which is the smallest one? It's a 2 by 3. Why? Because there are two things to discuss. First thing, if you express these one in decimal fractions, then 2 upon 3 is nothing but 0.6 recurring. 3 by 4 is nothing but 0.75. 3 by 4 by 5 is nothing but 0.8. 5 by 6 is 0.83, means at least 0.83 and more. So we have just we go on next. It is these are increasing. So to get the smallest, here it is 2 by 3. That is one thing to discuss. Second thing, let me tell you, if you analyze these fractions, then you will find two things. One is all are proper fractions. First thing, all are proper. With second thing, difference between numerator and denominator is constant. Whether it is 1 or 2 or 3 doesn't matter. If it is constant in proper fractions, 2 upon 3, 3 upon 4, 4 upon 5, 5 upon 6, 6 upon 7. In each corresponding fraction, corresponding numerator and denominator have the difference is of 1. Being the difference, common difference in all proper fractions, the fraction having smallest numerator as well as by default denominator also is the smallest. Is it clear? And because of that, we have the smallest fraction is 2 upon 3. Is it clear? Okay. Then next group of fractions we have 3 upon 2, 4 upon 3, 5 upon 4, 6 upon 5, 7 upon 6. So here we have to again get the same, which is the smallest fraction. So let me tell you, when you get all the fractions, you realize all are improper, with common difference between numerator and denominator in each is constant, and that is 1, right? So when all are improper fractions with common difference between numerator and denominator, then the fraction having greatest numerator as well as denominator is the smallest one. That is one thing. So because of that, it is 7 by 6. But more than this one, I would like to tell you, 3 upon 2 as well up to 7 upon 6 being all improper can be converted in mixed numbers. So we have 3 upon 2 is nothing but 1 upon 2. Are you getting me? 3 by 2, 3 when divided by 2, it is 1 quotient and remainder is 1, like that. 4 by 3 when converted in improper in mixed, it is 1 upon 3. Then 5 by 4 is 1 upon 4. 6 by 5 is 1 by 5, and 7 by 6 is 1 by 6. Here, as all of you know, being mixed numbers with integer part and fractional part, integer part is same for all, 1 each. So whatever is the comparison will be based on fractional part only. And because of that, 1 by 2, 2 by 3, 3 by 4, 4 by 5, just 1 by 2, 1 by 3, 1 by 4, 1 by 5, and 1 by 6. All are with common numerator. So the fraction with greatest denominator is the smallest. Is it clear? And because of that, 1 by 6, that is 7 by 6 is the smallest fraction. Is it clear? What is one? Okay. Next, please. 19 by 3, 43 by 7, 49 by 8, 31 by 5, 25 by 4. So as you find, all these are improper. First of all, these are to be converted in mixed numbers. So 19 by 3 is nothing but 6 1 by 3. Then 43 by 7 is nothing but 6 1 by 7. Then 49 by 8 is 6 1 by 8. Then 6 1 by 5 and 6 1 by 4. Each mixed number has integer part is 6, common to all. So the fractional part comparison is among fractional parts only, and among those fractional parts, 1 by 3, 1 by 7, 1 by 8, 1 by 5, and 1 by 4 all have common numerator. So the fraction with the greatest denominator is the smallest one, and hence we have 6 1 by 8. That is 49 by 8 is the smallest of all. Is it clear? Got this? Okay. Then last question from this comparison point of view, I would like you write down there. Arrange following fractions in ascending order. Ascending order. Ascending order means from smallest to greatest. In ascending order. So 3 upon 5, 4 upon 7, 2 upon 5, 7 upon 11. Please take these 4 fractions only. 3 upon 5, 4 upon 7, 2 upon 5, and 7 upon 11. Okay, so no doubt all of you are getting the same. We need to convert these common fractions into decimal. So here upon 5, no doubt it is when expressed in terminating, it is when it is expressed in decimal, it will be terminating. So 3 by 5 is nothing but 6 by 10. So 6 by 10, that is 0.6. Then 2 by 5 also one and the same. 2 by 5 means 4 by 10. So 4 by 10, that is 0.4. But now the second fraction, that is 4 by 7, when to convert, right? Here 4 to divide by 7, 4 is to be divided by 7. So up to 2 decimal places we are getting 0.57 like that, right? And for 7 by 11, we have here it is first 2 places are 2 decimal places are 6 and 3. Okay, listen, within no time you can do the same. 7 upon 11. Here the denominator is 11, no? So 11 when multiplied by 9, it is 99. So when we are getting both 9s in the denominator, so that means when it is expressed in decimal, it will be recurring decimal fraction with 2 digits. So that is 11 9s are 99. So 7 9s are 63. 63 upon 99 is nothing but 0.63 recurring. Like that, these are the basic things from calculations point of view. Okay, here we have to only bifurcate. We have to make it different only, not necessarily that exact value we have to get. We have to compare which is smaller, which is greater, like that. So 0.6 is nothing but, all of you can realize the same. 0.6 and 0.60 both are same. 0.4 and 0.40 are also same. Okay, so here in this one, now all are with 2 decimal places, and because of that we can arrange them in ascending order. So for ascending order, the smallest of all 4 is 0.40. That is nothing but 2 by 5. So 2 upon 5 is the smallest of all. Immediate next after 0.57 is 0.40 is 0.57. So that is 4 by 5, 4 by 7. Then we have the next is 0.60, that is 3 by 5, and last one is 0.63, that is the greatest one, that is 7 by 11. So this one is ascending order of the given fractions. Is it clear to all of you? All of you know, you just need to stick to basics only. Is it clear? Okay, so based on these, I would like to give you one question which was asked in our prelims 2020 again, the same question paper that we got. The question here. Okay, so question number 76. Question number 76. Which one of the following will have minimum change in its value if 5 is added to both numerator and the denominator of the fractions 2 upon 3, 3 upon 4, 4 upon 5, and 5 upon 6? Before doing any paperwork, please read the question again and again till you get meaning of the question. First of all, you should get meaning of the question. What is asked? Okay, listen. Are you getting meaning of this question? How many of you are getting meaning of the question? Please raise your hand. Don't hesitate. I will not ask anything. Just raise your hand. Okay. So for those who are not getting meaning of the question, let me tell you which one of the following will have minimum change. Minimum change after what? In its value, if 5 is added to both numerator and denominator. Original fractions, these are 4, 2 upon 3, 3 upon 4, 4 upon 5, and 5 upon 6. Each numerator as well as denominator of each of these fractions in which we are adding 5. So we get another fraction. So because of that, there will be difference between these two fractions. Which one? The first fraction and the fraction formed by adding 5 in numerator and denominator both. So these will be the differences with corresponding fractions, in which will be the smallest difference. That is nothing but minimum change. Are you getting me now? Is it clear? Now please try to get the answer. Okay. Yes, from online friends. Atreya, you are right. Okay, so as you are getting the same, this question was asking our claims. So we are not taking any chance. We have to solve the same. Otherwise, those who are preparing for other competitive exams, just as visualizing only, they get answer. That means the fraction which is the greatest of all these will have minimum change. So simple. So that is what here we have. Original fraction first is 2 upon 3. And the second one, by adding 5 in both numerator and denominator, it is, what will it be? 7 upon 8. So 7 upon 8 is but obviously greater than 2 upon 3. So because of that, we have making denominators equal 8. 8 3s are 24. And now 3 7s are 21 and 8 2s are 16. 21 minus 16 gives you 5. So the difference between first fraction and the fraction so formed is 5 by 24. Is it clear? Now the second is 3 by 4 given. Each when added 5 in both numerator and denominator, we have 8 upon 9. So we have 8 upon 9 minus 3 upon 4. 9 4s are 36 is in the denominator. In the numerator, we have 4 8s are 32 and 9 3s are 27. 32 minus 27 gives you again 5. So we have 5 upon 36 is the next difference here. No doubt 5 upon 24 and 5 upon 36, which is the smaller? 5 upon 36 is the smaller. So as we go on increasing, we have the difference between these two is decreasing. How it is? We have the next 4 upon 5 and the fraction so formed is 9 by 10. We have to make it 10 by 10 into 5, first of all 50. 9 5s are 45 and 10 4s are 40. 45 minus 40, that gives you 5 again. So 5 by 50. And last here 5 by 6. When another fraction is formed by adding 5 5 in each numerator and denominator, we have 11 6 are 66, 10 6 are 60 minus 11 5 are 55. So again it is 5 by 66. All these differences have numerator is common, that is 5 only. The fraction with greatest denominator is the smallest. So minimum change, as it is asked, minimum change, which is it? 5 by 66, that is in the fourth of the fraction. So that is option D is the correct answer. Are you getting me? So from logical thinking point of view in maths, as I said it, fraction with the values greatest is with by the same condition given will be the minimum change in that. Is it clear? As we are having, see, 2 upon 3, 3 upon 4, 4 upon 5, and 5 upon 6. As we go on increasing, the difference between any two successive is go on increasing. How it is? Let me tell you. Here we are having this as we got in this one. 2 upon 3's value is 0.6 recurring. For a while we can get 0.66. Okay, here it is 0.75. How much is the gap between these two? 0.9 approx. 0.09. Then we have here 0.75 and 0.80. 0.05 now. So difference between these two has decreased. So that is what, as I'm saying, the fraction with the greatest value with the same condition given, same instruction to be followed. Then we have the minimum change happens in case of the greatest fraction. Is it clear? Okay. So we had to get this. Sorry, was the screen shared? Okay, sorry. Just a minute. Here in this one, 2 by 3, that is 0.6 recurring, that is 0.66, 3 by 4, that is 0.75, 4 by 5 is 0.8, so that is 0.80. So 0.66 and 0.75, the gap is of 0.09, then 0.05, again 0.03 approx. So it goes on decreasing when we are adding common number, common one only. So same it happens with common plus 2 plus 3 plus 4 plus 5 like that. Is it clear? Okay. All right. Now, so these are all the basic things from fraction point of view. Now you are able to solve questions related to fractions in competitive exam. First of all these basic things you must know. What are meaning of the fractions, then types of fractions, then conversions of fractions, then comparison of fractions. At last but not the least, all of you know operations on fractions. So how to add fractions, how to subtract fractions, how to multiply fractions, and how to divide fractions. So basically, first of all, just to check yourself, you will only judge yourself. So please solve one example. Add 5 upon 12 plus 4 upon 15. Please do this one. You may ask me, is such a question be asked? No doubt such a question will not be asked. But in case of time and work questions, we need work done to be done in a unit period of time. In that case, there is a fraction. So when 2 or more persons are doing that work together, then we need to add those work done in unit period of time, which are in fractions. So addition, subtraction are needed there. So 5 upon 12 plus 4 upon 15. Don't answer loudly, all of you will getting the answer. You all will get answer. Correct answer only. I believe in this thing. So some of you may getting answer 41 upon 60 to the lowest terms, or some may be doing up to 123 upon 180 only. Is it clear? One and the same. Answer both are same, but to the lowest term 6, it is 41 by 60. We have to make denominators equal while making addition or subtraction. For that, what we do, both are to be multiplied themselves, or otherwise taking LCM. So 12 is to be multiplied by 15. So not to change its value, 5 is also to be multiplied by 15. 15 is multiplied by 12. So 4 is also to be multiplied by 12. And because of that, we get 75 plus 60. Sorry, 75 plus 48 upon 12 into 15. So don't try to get multiplication even if you are able to that, because cancellations are on cards. So we have 75 plus 48, that is 123 upon 12 into 15. So as soon as we see the number 123, we realize that it is divisible by 3. Even if both the numbers in the denominator are divisible by 3 each, we have to divide only one by that 3. Okay, so we have here it is 41, and when 12 is divided by 3, it is 4. So because of that, 41 upon 60 is the addition to its lowest terms. Okay, all of you can add as well as subtract also. If we have in subtraction, then 75 minus 48, whatever the number, that is 27 upon 12 into 15, whatever we are getting in case of subtraction. In case of multiplication, as we know, fraction, so which are involved in multiplication, numerator and denominator. If there are common divisors, then first of all divide any numerator and denominator by the same number, and after getting all divisions, the product of numerators is in the numerator and that in the denominator. Same it is in case of division also. For example, a divided by b, so a upon b divided by c upon d. So right from our school days we know divided by means multiplied by its reciprocal. So a upon b divided by c upon d, that is a upon b multiplied by its reciprocal d upon c. Is it clear? Not this one? Okay. So these are all basic things we need to know to solve each of these questions from question papers. Now, in your question bank given questions, we can start with the first question, but total questions given are 25. Out of those, a few questions will solve here in our classroom, because the rest of the questions I know that you can do better. Means you can solve those. Okay. So here, fractions. First question: choose the fractions which are in descending order. It is said descending order. What do you mean by descending order? The first is greatest, and then go on decreasing smallest. So descending order is nothing but decreasing order. So choose, that means we have to go through options. So first set, second set, third set, and fourth set. Out of these 4 sets, in one set, these are in descending order. What is that set? So here, option A is the answer. Listen, all these are to be expressed in decimal fractions. So 2 by 3, first we have to check each of these options. 2 upon 3 is nothing but 0.6 recurring. 3 upon 5 is nothing but exactly 0.6. Then 1 upon 2 is 0.5. Because of these values, we can compare these. 0.6 recurring is the greatest, then 0.6, then 0.5. So we have these are in descending order, that is decreasing order. So only in the first set. You may think second, third, and fourth. If it is all rest second, third, and fourth by chance in ascending order. Why is it so? 1 upon 2 is 0.5. 4 upon 6 is nothing but 3 upon 4, that is 0.75, and 6 upon 8. Just a second, sorry. 4 upon 6, that is 2 upon 3. So 2 upon 3, that is 0.6 recurring, and 6 upon 8 is nothing but 3 upon 4, that is 0.75. So we have these are in ascending order. Same is the case this one also, as well this. All are numerators 1 each. Then the fractions with greatest denominator is the smallest, and the smallest denominator is the greatest. Because of that, these are in ascending order. So we ask in descending. So that is option A is the answer of this question. Is it clear? Okay. So after this first question, we'll switch over to the question number 4 directly. Second and third we will solve at home. Okay. Now question number 4. The sum of the first 35 terms of the series. Series given has first term is 1 by 2, second term is plus 1 by 3, third term is minus 1 by 4, fourth term is minus 1 by 2, fifth term is minus 1 by 3, sixth term is plus 1 by 4, seventh term is again plus 1 by 2. Is it clear? Okay. Listen. Let me tell you, first of all, reference of this question. This question was asked in one of the exams conducted by MTSC, in which each question had to be solved in 36 seconds only. Is it clear? even though we are asked to find the sum of first 35 terms, we are not supposed to write all those 35 terms, right? Here, but we should get what is pattern followed in this way. Because of that, we can think of all 35 terms. Is it clear? So, as I said it, first term is plus 1 by 2, second is plus 1 by 3, third is minus 1 by 4, fourth is minus 1 by 2, fifth is minus 1 by 3, sixth is plus 1 by 4. Now, seventh is again plus 1 by 2. That means whichever is the first term, same is the seventh. Whichever is the second term, same is the eighth. We have plus 1 by 3 like that. Whichever is the third term, same is the ninth one. So after every 6 terms, same term it comes. Is it clear? So because of that, we can say groups of 6 terms each are formed. Is it clear? And because of that, we have now here in 6 terms of first 6 terms, we have plus 1 by 2 minus 1 by 2 cancelled, plus 1 by 3 minus 1 by 3 cancelled, minus 1 by 4 plus 1 by 4 cancelled. All 6 terms are cancelled. First 6 terms are cancelled. Such every 6 terms will be cancelled. Like that till 35th term, groups of 6 each. How many groups we have in there? 5 groups. 6 5s are 30. So till 30th term, all will be cancelled. Is it clear to all of you? All 30 terms will be cancelled. Now 31st term is one and the same, which is first one here. Then 32nd, 33rd, 34th, and 35th. We have these, of which first and this one is cancelled. Then second and fifth one will be cancelled. What is left over there? Minus 1 by 4 is the answer. So option D is the answer. In this way, in exam, what we need to do? Is it clear? Okay, finished. Now switch over to question number 10 directly. Such kind of a question is very common in other competitive exams like Staff Selection Commission, management entrance exams. So we also maybe ask such a question. So what is question given? The sum of first 20 terms of the series. The series has first term is 1 upon 5 into 6. Second term is plus 1 upon 6 into 7. Third term is plus 1 upon 7 into 8. Like that. How many terms are to be added first? 20 terms, right? So even though we are not supposed to write all those 20 terms, we should get what is the 20th term. First of all, what is 20th term? So here in first term, we have numerator is 1, denominator is 5 into 6. Each term has numerator is 1, which is common to all, and that's why it is in 20th term also it will be 1. Now you have to tell me what would have been the numbers in the denominator of the 20th term. In the last term, that is 20th term, which will be the numbers in the denominator? Okay. Are you getting? No. Yes, please raise your hand and then tell. Yes, 24 into 25. For those who are not getting, for them, let me tell you. First term is with the smaller number 5. Second term with smaller number 6. Third term with smaller number 7. So each next term is smaller number as well as greater number increasing by 1 only. Is it clear? So first term is started with 5. If it had been started with 1, that is instead of 5 into 6, if it would have been 1 into 2, then what would have been the 20th term? 20 into 21. Are you getting me? Here, first term is started with 1. First term is 1. Then 20th term will be 21, it is a smaller number. But here, how many, by which number it is started? By 5. How many, first, how many terms are skipped? 4. So we have to extend by 4 only. That is what it should be 24 into 25. Is it clear? Got this one? If you don't like this explanation, we can have another also. What is that? Listen. The term number 1, term second, term third, each. Okay. So first term, the term is first, but the smaller number is 5. Term is second, the smaller number is 6. Term is third, smaller number is 7. So in each term, whatever is the number of term, smaller number is having greater by 4. So that is what here 20th term, smaller number will be exceeding by 4 only. So that is 24 into 25. Is it clear now to all of you? Okay. Now what next? How to solve? Please tell me. We'll discuss the same. How to solve this one? What will be in your mind if you come across such a question in exam hall? How to proceed? Okay, listen. 1 upon 5 into 6, that means 1 upon 30. 1 upon 6 into 7, that is 1 upon 42. 1 upon 7 into 8, that is 1 upon 56, like that. How many total terms would have been there? 20 terms, right? So to add 20 terms, all are having different denominators, making these equal. It is highly, what you may say, time consuming and all these. We are not supposed to make all the denominators equal. So in that case, listen, simplification is required. So from simplification point of view, let me tell you, as we are having plus signs among any between any two successive terms plus sign. If we had multiplication, then we would have cancelled the common numbers between numerator and denominator. But right now we can't do like that. So, but cancellation is must. Then and then only this can be solved. So for cancellation here, we need to simplify this one. We can't make these changes. We have to put plus signs there only. Now, let me tell you one most important sentence from this. What is it? Each term needs to be expressed in subtraction of two fractions. Because of that, only cancellations will be there. As it is plus sign will be cancelled only by minus. Are you getting me? So let me tell you, 1 upon 5 into 6 is a result of subtraction of two fractions we have to get. Are you getting me? Okay, so you have to find those two fractions whose subtraction will be 1 upon 5 into 6. Listen, whatever may be the numerator, denominators of these fractions have to be 5 and 6. Are you getting me? You are present here. Are you getting online, friends? Okay, so any number in the numerator upon 5 minus any another number upon another same upon 6 will have the subtraction in the denominator is 5 into 6. Is it here? Now, the digit in the number in the first fraction in the numerator multiplied by 6 and means here whichever may be the digit multiplied by 6 minus 5 into the digit at the number at this place. Is it here? Should be differ by how much? 1 only. Already 5 and 6 have the difference is 1. That means even if we multiply, it remains the same, difference remains the same. That means by which number we have to multiply? By 1 only. So in other words, here we have this one is 1 upon 5 minus 1 upon 6 is 1 upon 5 into 6. Why? Because 6 ones are 6 minus 5 ones are 5. So 6 minus 5, that is 1 upon 5 into 6. Is it clear to all of you? Listen, if it is explained in any book, you will be given direct step how it comes that we are discussing. Is it clear? So you need to get each term to be expressed as difference between subtraction of two fractions. Subtraction of two fractions. So here 1 upon 5 into 6 is nothing but it can be expressed as 1 upon 5 minus 1 upon 6. Is it clear? Now then what will be with 1 upon 6 into 7? All of you are getting plus 1 upon 6 minus 1 upon 7. Then for the third one, 1 upon 7 minus 1 upon 8. Like that for the last one, plus 1 upon 24 minus 1 upon 25. Is it clear? 20th term is 1 upon 24 into 25. 19th term should have been 1 upon 23 into 24. That is what? Plus 1 upon 23 minus 1 upon 24. Is it clear to all of you? Now friends, from second term to second last term, all are cancelled. How it is? Minus 1 by 6 plus 1 by 6. Minus 1 by 7 plus 1 by 7. Minus 1 by 24 plus 1 by 24. So what are the terms left? Only first and the last. Which is the first term? 1 upon 5. Which is the last term? Minus 1 upon 25. We have to make denominators equal, that is 25 is the LCM. 5 has 25. So in the numerator also 1 needs to be multiplied by 5 minus 1 here. So 4 upon 25 is the answer. Is it clear? But all the options given are in decimal or complete numbers. And because of that, this can be this is to be converted in decimal. So because 25 into 4 is 100. So 4 is also to be multiplied by 4. So it is how much? 16 upon 100. That is 0.16. Is it clear? Got it? So please copy this one. I would like to give you some more things regarding this one. 2 more things I would like to give you regarding this one. First of all, please copy this. Finished? Okay. Let me tell you. To get answer of this question, going through options also, it will take very less time. How to get that one? Let me tell you. But for that, options should be adjusted so that we can easily eliminate those. Okay. So right now, here first term is 1 upon 5 to 6, that is 1 upon 30. Second is 1 upon 42. Third is 1 upon 56, and so on. Comparing first and second term, 1 upon 30 and 1 upon 42, which is the smaller one? 1 upon 42 is the smaller. So that is what? Now 1 upon 30 and 1 upon 42, 1 upon 42 is smaller. From 1 upon 42 and 1 upon 56, the third one. Again smaller is 1 upon 56. So as we go on next term, we get that in descending order. Is it clear? So the value of the first term is the highest, greatest. So the first term is 1 upon 30, no? 1 upon 30. 1 upon 3 is 0.3 recurring. 1 upon 3 is 0.3 recurring. So 1 upon 30 is 0.03 recurring. Is it clear? So value of the first term is 0.03 recurring. And the second term onwards, the values are in decreasing, right? For a while, I'm saying, for a while, you have to imagine, for a while, each of these terms have the same value, 0.03 at least. So sorry, at most, 0.03 recurring. So how many terms are there? 20. So that is what? This sum will be 0.03 recurring into 20. It will not exceed that, I'm saying. It will not exceed that. So 0.03 recurring into 20, it will be 0.6 recurring. Is it clear to all of you? 0.6 recurring. Okay. So our answer is not exceeding 0.6 recurring. As soon as we realize this, we can easily eliminate option C and D. Option C and D are no more. Is it clear? These are far more than 0.6 recurring. Then option B can't be our answer. Why? Because whatever the option B, no, 0.16 given, which is smaller than value of the first term itself. Value of the first term is 0.03 recurring. Less than that, only the option B. So that also can't be the answer. So option B, C, and D are eliminated. That's option A is the answer. Is it clear? So that is elimination. You may do like this also. So when such a question is asked in exams in which each question is to be solved in 36 seconds like that, we need to do like this one. Okay. After this, let me tell you one more thing regarding this one. I would like to tell you. See, means maximum things I would like to give you from conceptual point of view. Basic things. 1 upon 5 into 6 is the first term given, and 1 upon 6 into 7, the second term is given. Okay. Suppose we are first two only. We are doing this one because some may get shortcut like that, but it happens only when numerator for each of these common, that is 1, and denominators are just like as two positive numbers from natural numbers like that, and ascending order. If we add these two only in the denominator, it will be 5 into 6 into 7. Are you getting it? Okay, so 5 into 6 needs to be multiplied by 7, so numerator also. Is it clear? 6 into 7 is to be multiplied by 5, so numerator also. So we have 12 upon 5 into 6 into 7. Now here 6 ones are 6, 6 twos are 12. So the answer is 2 upon 5 into 7. Are you getting me? First thing. Now second thing I would like to give you. Here 1 upon 5 into 6 plus 1 upon 6 into 7. And now suppose we are adding the third term also, 1 upon 7 into 8. We have the denominators of 5 into 6 into 7 into 8. Is it clear? Now already it is 5 into 6 in the first denominator. What are not the factors from this 7 into 8. So by 7 into 8, we have to multiply 1 in the first. Now, in the second, 6 into 7 is already there. 5 into 8, we want 5 are 40. Plus 7 into 8 is already there in the third. We have 5 into 6. 5 6 are 30. So we have 40 plus 30, 70 plus 56, that is 126 upon 5 into 6 into 7 into 8. Now here it is. 6 ones are 6, 6 twos are 12, and 6 ones are 6. 7 ones are 7, 7 threes are 21. So we have 3 upon remaining in the denominator is 5 into 8. Are you getting me? Is it clear? Now, if you analyze, when we are adding first two terms only in the numerator 2, when we are adding first three terms in the numerator, it is 3. In the denominator, when we are adding first two terms, the denominator of this one is 5 into 7, that is extremes. Then in the denominator of the addition of three terms, 5 into 8. Is it clear to all of you? Now, in the given example, how many terms are to be added? 20. So in the numerator, it has to be 20. In the denominator, extremes are 5 and here what should it be? 25. Is it clear? So we have 5 ones are 5, 5 fours are 20. So that is 4 by 25. As you got the answer, 4 by 25. So when it is expressed in decimal, it is 0.16. Is it clear? So if you are getting in exam or something, so we have the same. That is when all the terms have the numerator is common, that is whatever it is, 1 or 2 or 3. If it is 1, then no problem. If it is other than 1, then we are taking that one as common. And when we are having two consecutive natural numbers and these are in ascending order, then we have in the denominator resulting first extreme, that is the smallest one, and the last, that is the greatest one. We are getting that one and multiplying. We can have the same. Is it clear? What this one? Okay. Then we'll switch over to the next question now. Question number 12. Okay. So the answer is, how many of you are getting option D? Please raise your hands. Okay, for others and all of you. Here, the given expression can be described as a fraction whose numerator is 1 only, rest all is denominator. So that denominator is to be simplified. So because of that, here in 3, means in the denominator we have in the integer 3, we are adding again a fraction whose numerator is 1. So in the end, we are adding 1 by 3 in 3. Integer 3 plus 1 by 3 is 10 by 3. As you know, 3 3s are 9 plus 1. 10 by 3 is a denominator whose numerator is 1. Such a fraction is subtracted from 3. Are you getting? So for that, what we need to do here, 3 plus 1 by 3 is 10 by 3. That 10 by 3 when taken to the numerator, it is 3 by 10. Are you getting me? 1 upon 10 upon 3. 1 upon 10 by 3, that means 1 multiplied by 3 by 10, that is 3 by 10 only. So 3 minus 3 by 10. 3 minus 3 upon 10, that is 10 is a 30 minus 3, 27 upon 10. So 27 upon 10 is the denominator whose numerator is 1. So that is what? 10 by 27 is the fraction added in 3. Is it clear? So I would like to tell you, this one is, what is it? 10 by 27. Now in 3 it is added. So 27 3s are 81 plus 10, 91 upon 27. 91 upon 27 is the denominator whose numerator is 1. Such a fraction is our answer. So 1 divided by 91 upon 27 is nothing but 27 upon 91 is the answer. That is option D is the answer. Is it clear? Okay. So that was question number 12. All of you might have getting the same. Okay. Now question number 13. In case of 13th question, I know that all of you will give me correct answer, but you have to tell me how do you get that one. Okay. So are you ready with your answer? Okay. So how many of you have your answer is option D? Okay. Can anyone interested in explaining this one? How do you get that one? Okay. Absolutely correct. How can you eliminate? Okay. Hmm? Okay. Can you explain? Yes. Okay. From elimination, you can get answer. No doubt. But suppose we have to solve this one. Then how to get the answer? Now I would like to ask you, how many of you have solved by assuming variable x? Please raise your hand. Ah, correct. Those who have not used any variable, they are maybe getting close to one, or maybe assuming that it is nothing, so we have to put as one like that. Is it clear? So it is not here. It is not nothing. Let me tell you. Actually, it's not a joke, but I would like to tell you one thing. This question was asked in one of the exams conducted by MPSC. So the candidate who appeared in that exam came to me and told me that, sir, what happened? MPSC has missing that whatever is not written. Are you getting me? So it is not missing. It is infinite. It is continued. It is continued for infinite number of terms. So that is what we have to assume. Any variable. So as I explained this one, means explain that infinite terms if there are in decimal fraction, then we assume that one as x. Listen, in the given expression, how many terms are there? If it is asked, then these terms are infinite. So from anywhere, if you start, it is the same. So let this be as any variable. It is x. So 1 upon 2 minus, again 1 upon 2 minus 1 upon 2 minus, it is continued. So if we do 1 upon 2 minus, this one is also x. Are you getting? Is it clear? Listen, being infinite terms, you can't say when one term is taken out, then remaining is minus 1. No, because these are infinite terms. Suppose there have been only 10 terms. After taking out first term, remaining are 9. Suppose there are 100 terms. After taking one term out, we have remaining is 99. But being there are infinite terms. After taking first term out, rest also infinite terms. Are you getting me? So that is what the rest is also x. So we have to put like this one. Is it clear? Yes, no, yes. Okay, you can say no also. I'll repeat the same. Okay. Now, so from cross multiplication and all these things, 1 into 1 is 1. X into 2 minus x. So 1 is equal to 2x minus x square. Listen, friends. Minus x square when taken to the left, it will be plus x square. Plus 2x when taken to the minus, it is minus 2x. And plus 1 already there is equal to 0. Are you getting me? X square minus 2x plus 1 is equal to 0. Then you can realize here you will realize x square minus 2x plus 1 is expansion of x minus 1 bracket square. Is it here? Is equal to 0. That is x minus 1 is equal to 0. And because of that, x is equal to 1. And hence the answer is option D. This is correct mathematical explanation. Is it clear? Please copy this one. So you write let the given expression as x. Okay, finished. Till then, we'll do by going through options. As you can eliminate options. How it is? Let me tell you. The question is, what is the value for the following division? Following division. The division has the number to be divided is numerator is 1. Rest all is denominator by which it is to be divided. Listen, option B, that is 0, cannot be the answer. Why? Because the division value of the division 0 is possible only when the number to be divided has to be 0. Are you getting? The number in the numerator, if it had been 0, then the answer would have been 0. But numerator is non-zero. That is why 0 can't be the answer. That is first thing. Is it clear? Listen, in exam hall, suppose someone doesn't get what is given in this one, then being panicked, one may think that it is infinite terms. So 1 upon infinity is 0, no, but infinity is of two types. One infinity that is not defined, can't be defined, that is one infinity, and second one is infinite number of terms. Here it is infinity is infinite number of terms, so it is not 1 upon infinity, that is 0. So 0 can't be the answer. That is one thing. Second is option C can't be the answer, -1. Why? Because numerator is 1, that is positive. Denominator, whichever it may be, from 2 it is subtracted. Is it clear? So when we have 2 minus any number, which is approximately maximum 1, so 2 minus approximately 1 only, so the denominator has to be again positive only. So positive divided by positive is positive only, so answer can't be -1. So option B and C are eliminated. Is it clear? Now option A can't be answer. Why? Because 1 upon, here to have answer 2, 1 upon 1 by 2 should be there. Are you getting? 1 upon 1 by 2 will be 2. So that is what 1 by 2 cannot be possible, because from 2 it should be subtracted 3 by 2. Then and then only it will be 1 by 2. But this one cannot be 3 by 2, because all the time whatever is the numerator and denominator is greater than the numerator, and hence it cannot be exceeding 1. So it can't be 3 by 2. So 2 minus 3 by 2 cannot be possible, and that's why answer can't be option A also. Is it clear? So these three options are eliminated, option A, B, and C. Hence answer is option D. Is it clear? Or otherwise, one more thing I would like to explain or discuss with you, and that is what? Listen, in previous example it was stopped here only. Same is the thing. Suppose we assume this is 2 minus again. So if we stop here only, is it clear? What will happen? In the denominator, we have 2 minus 1 upon 2. Are you getting me? 2 minus 1 upon 2. How much it is? 3 by 2. Why? Because 2 2s are 4 minus 1, 3 by 2. So this one is 3 by 2. When taken to the up, it will be 2 by 3. Are you getting me? This circle has a value term inside the circle is 2 by 3 is subtracted from 2. 3 2s are 60, 3 2s are 6, minus 2 is 4 by 3. So 4 by 3 is the denominator. When taken to the up, it is 3 by 4. Are you getting me? Now, this 3 by 4 is to be subtracted from 2. 4 2s are 8 minus 3, 5. 5 by 4. When taken to the up, it is 4 by 5. So you will find innermost is 2 by 3. When one term is added, 3 by 4. When again one term is added, 4 by 5. Like that. Is it clear? So if it had been again one term added, it would have been 5 by 6. Like that. So for n terms, it will be n upon n plus 1. Are you getting me? So limit tends to infinity. Here it will be close to 1, closest to 1, but it will not exceed 1. Is it clear? Even though it is close to 1, that means approx it will be 1, very much close to 1. So that is what answer is option D. Is it clear? Got it? Okay. So that was 13th question. Then we have the next some questions are very simple one, that is subtraction of decimal fractions. So subtraction of addition, subtraction, multiplication, and division of decimal fractions are same as that of numbers. Only we have to think of decimal points. Okay. So right now here very basic thing. Suppose as we have these three numbers in the given expression. First number is 12.3456. Next two terms are both with negative sign. So when two numbers are with negative sign, what we do? We do addition and put minus sign to both. So we have here 6.23 and 5.0045. We add these two. So as you know how to add or subtract, put equal number of decimal places there. Addition, it comes this one. So this is to be subtracted from the first number. So we have the answer is like this one. All of you can get this. Is it clear? So option C is the answer. Okay. Now you just try to solve yourself 15th one. 15th. Okay. Here the answer is the D. Okay, we'll do. No problem. Others, please do first of all. Okay, see, how many of you have got your answer option D? Please raise your hands. Okay, option D, no? Listen, those who are not getting for them. 3.6 is one number, 0.4 is another, 0.48 is another number, and 2.50 is the third number in the numerator. These are multiplied. So we have, suppose we do, instead of 3.6, that is 36, then 48, and 250. That means how many decimal places are shifted? So 1, then 2, and 2. 1 plus 2 plus 2, how many? 5. So into 10 raised to minus 5, we can write. Are you getting me? 5 places are shifted, the decimal point, and because of that to have the same, we have to divide by 10 raised to 5, that is 10 raised to minus 5. Now here in the denominator 0.12, 0.09, and 0.50, of which here if we shift to each 12, 9, but here instead 50, what we do here 10 raised to minus 5, that means we can just get 5 decimal places only, of which here these are 2, here these are 2 again, and instead of here 2, only 1 is to be shifted. Are you getting me? Why is it so? Because in the numerator only 5 places are shifted, the decimal point is shifted by 5 places in all together. Same is the case in the denominator. Is it clear to all of you? Is it clear? So 10 raised to minus 5, 10 raised to minus 5 we can say. In other words, both numerator and denominator are multiplied by 10 raised to 5. In other words, is it clear? So now from calculations point of view, till this, is it clear to all of you? 12 3s are 36. Here, okay, no problem. 3 1s are 3 3s are 3 1s are 16 3s are 48. Then we have here is 50. 16 into 50 gives you 16 5s are 80 into 10, that is 800. So the answer is option D. Is it clear? So whatever these are the calculations that is the next part, but before that, very basic thing is shifting of the decimal point by how many decimal places it is shifted. So that was the question number 15. Is it clear? Then 16th question, you all present here will get answer within no time. Listen, 0.3333 recurring, that is 3 by 9, into 0.6 recurring, that is 6 by 9. So we are here, it is 3 1s are 3 3 3s are 9, 3 1s are 3 3 2s are 6. So what is calculations? 2 by 9, that is option B. 0.3 recurring, that is 3 by 9, 0.6 recurring, that is 6 by 9. In this way only we have to solve. Then let me tell you, anywhere, suppose, listen, it looks very simple that we are having the 17th question. just shifting of the decimal point. Okay, this will help you in solving questions related to conversion of quantities given in different units, like in metric system of units, kilo, hecto, deca, deci, centi, milli, then cubic centimeter, cubic millimeter, like that. Okay, so we need to know first of all the basic things. Here given is 57.33 upon 63 is equal to 0.91, already given. Now ask is 5.733, means whatever is given relation in which a numerator is with the same, only shifting of decimal point is there. Is it clear? Now, but in the denominator which is asked is 0.0091, that is this one is taken to the left and has to be in the denominator only. Because of that, this 63 will be transposed to the opposite, so will be in the numerator. So that is what, let me tell you, 57.33 upon 0.91 is equal to 63. Are you getting it? Is it clear? Okay. Now to have answer and in minimum changes we have to get in, means we have to use only simple concept. What is it? In the denominator we are asked 0.0091. Is it clear? And here we know that here only 0.91. So if we are shifting this decimal point by 2 places to the left, here in the numerator also not to change its value, it is to be done. Are you getting me? So what is it then? This decimal point will be here. So 63 is answer when 0.5733 upon 0.0091. Answer is 63. Is it clear? But so we have made denominator is same as which is asked. But in the numerator here, instead of 0.5733, it is decimal point to the right of 5. That means it is shifted by 1 place to the right. So in the answer also decimal point will be shifted to the right, and hence answer will be how much it is? 630. Is it clear to all of you? In simple language, we have to make denominator equal. Then whatever are the changes in the numerator, we can get the change in the same in the numerator answer. Numerator of the answer. Is it clear? As we got. Till this it is okay, that is 0.5733 upon 0.0091 has to be 63. But here the numerator is not only 0.5733, it is multiplied by 10. The numerator is 10 times of the relation in this one. So answer is also 10 times of the this 163. So it is 630. Is it clear? Okay. So please practice yourself the same thing. Okay. Then we have the next 18th one. So answer is option C is the answer. Let me tell you. Here 2.1 and 36 recurring. That bar is on 3 and 6. Is it clear? Okay. So how to work out this one? 2 integer. Now from among the digits in decimal part, 2 digits are repeating again and again. That's why 99. 1 digit is not repeating, single 0. In the numerator, number found by all these digits in the decimal part is 136. Minus what to do? Minus 1. That the digit which is number found by the digit which is not repeating, that is 1. So we have 2 integer 135 upon 990. So to the lowest terms we need to get to the lowest terms. So as soon as we see these numbers 135 as well as 990, both are divisible by 5. So because of that we have here it is 27 and here it is 198. Now 27 and 198 both are divisible by 9 each. 9 3s are 27, 9 2s are 18 plus 190, again 9 2s are 18. So here it is 2 integer 3 upon 22. That is option C is the answer. So in such examples there are 2 things. First of all, you should know what is the procedure to be followed. Second, calculations must be correct only. Is it clear? So after these this 18th question, here 19th, 20th, 21st, 22nd, these questions are to be solved when you get spare time. Not necessary to solve these when you have time, because these are complicated calculations, but these are asked in some of the exams, competitive exams. Just a minute. So let me tell you one thing. In question number 22nd, there is correction. Yes, there is correction. In question number 22nd. So we have 78 upon 13 into 49 upon 12. No, so instead of that 12, make it 42. First of all, one of the corrections. I'm saying there are 2 corrections in the same. Here instead of 12, it is 42, and instead of 25, make it 35 here. So because of this one, now you will not be frustrated if you are not getting answers. Is it clear? Got this one? No, just a minute. What happened? Something goes wrong. Just a minute. Listen, in 23rd question, it is, we are not solving, don't take tension. You will solve yourself. So it is told in a rectangular bracket 3 1 by 4 divided by in curly bracket 1 1 by 4 minus 1 by 2 in brace bracket 2 1 upon 2 minus what is given here 1 upon 4 minus 1 upon 6, and it is put vernacular or bar. It is not recurring. Are you getting me? Recurring is only in case of decimal fraction. Means some of the students in other class they ask me, is it recurring? No, it's not recurring. Recurring is in case of decimal fraction only. It is vernacular. Just we have seen in second topic, that is V formulas. So that vernacular. So this is to be solved first of all, and then the rest of the things are to be done. Is it clear? So shall we solve this 24th question? Yes. Listen. Got it? Answer. Okay. Can you back also? Listen. In one of the exams, it was asked. Listen. 1 cube plus 2 cube plus 3 cube up to 9 cube is 2025. If it had not been given, then also we have got by formula. Sum of cubes of first n consecutive natural numbers. Listen. We are asked to find the value of 0.11 cube plus 0.22 cube plus 0.33 cube up to 0.99 cube. Isn't it? Listen, whatever we are using these things that is conceptual, you may be asked related to these things in different questions like that. So here, if we think that 0.11, 0.22, 0.33 up to 0.99, all are multiples of 0.11. Is it clear? So because of that, we can express this one as 0.11 into 1 is the first term. That is 0.11 into 1 cube plus 0.11 into 2 cube plus 0.11 into 3 cube like that. Up to the last term is 0.11 into 9 cube. Isn't it? Now, here, as we know from laws of indices, a into b bracket raised to m, that is a raised to m into b raised to m. So because of that here, 0.11 cube into 1 cube plus 0.11 cube into 2 cube. In that case, we are taking 0.11 cube common. So in the bracket, we are left with 1 cube plus 2 cube plus 3 cube up to plus 9 cube. Are you getting me? Is it clear? Now, 0.11 cube. First of all, we have to get 11's cube. 11's cube is 1331. Isn't it? Into, let me tell you, 10 raised to minus 6. Are you getting me? 0.11 cube, that means 0.11 into 0.11 into 0.11. That is, there will be 6 decimal places. That's why we are getting 11's cube into 10 raised to minus 6. Now, into this rectangular bracket, it is the only right time to use whatever is given. 2025, 1 cube plus 2 cube plus 3 cube up to 9 cube. Is it clear? Now listen, in book you will be given direct answer afterwards. Instead, what I would like to tell you from practical approach, 1331 into 2025. After doing that one, we have to shift that decimal point by 6 digits to the left. Instead, you can do from practical approach 3 each. That is what 1.331 into 2.025. Why are we doing this one? Because by shifting that decimal place to the left, here 2.025 means approximately 2, very close to 2. 1. It's a double. It's 2.662. So closest option to 2.66 is what? Option C. In this way, we need to get. Are you getting me? So whatever may be 10 raised to minus 6, minus 4, minus 5, you need to get here which will be the closest integer. Which will be the closest integer, like that. Is it clear? So here 2.025, closest integer is 2. Like that, we can get the answer. So answer is approximately, no doubt, option C, that is 2.695. Okay. So we have today we have done the topic that is fractions. 3 or 4 more examples related to fractions we'll be doing in the next lecture first of all, and then we have the next topic that is HCF and LCM. One of the most important as well as favorite topics from our exam point of view. HCF and LCM. Okay. So online friends as well as offline for today's lecture, this much only. Thank you all of you. Stay safe. Take care.